Imagine trying to twist a solid steel pipe that's literally 2 kilometers long, fighting against the immense friction of an entire deepwater wellbore and twisting it hard enough to actually break solid rock at the bottom. That is what we're diving into today in this explainer. No slow intros today, we are jumping right into the mind-boggling mechanics of extreme torque. Doing that requires a level of rotational muscle that's kind of hard to wrap your head around. We're talking 105,000 foot-pounds of continuous torque. And modern vessels carry 2 of the units that produce this, plus 2 reliable backups. Because losing your ability to rotate pipe mid-well, yeah, absolutely not an option. To put that visceral number into perspective, 105,000 foot-pounds is basically equivalent to the sustained twisting force of a fully loaded semi-truck's drive shaft, and you're pushing that massive energy through miles of pipe directly down to the bit. As one of our sources perfectly puts it, it's enough to twist your drill string completely out of shape, like a piece of toffee if you aren't careful. Okay, let's look at the primary rotation muscle making all this happen, the mighty top drive. What's truly incredible is the sheer scale of this hardware. We're talking about twin NOV TDX 125 top drives. They hang directly in the derrick, acting as these infinitely controllable alternating current electric motors. And they boast a massive 1,250 short tons of hook load capacity alongside that staggering 105,000 foot-pounds of torque. But here's the insight a lot of people actually miss. The top drive's true advantage isn't just its raw power, it's the operational flexibility. Think of it like a giant powered socket wrench riding up and down the derrick. Its real superpower is that it can rotate the string from above and circulate drilling mud and make pipe connections without ever stopping rotation. That is a massive boost to efficiency. So let's shift gears slightly and look at the physics of drilling to really understand our limits. What exactly is torque in this context? Well, simply put, it's the rotational force applied at a distance from the axis of rotation. Practically speaking, for our top drive, that means it can apply the equivalent of 105,000 pounds of force at a 1-foot radius to spin the string against all that intense downhole friction. And this brilliantly illustrates why we focus so heavily on this simple formula. Torque equals force times lever arm. It's why torque, rather than simply horsepower, is the absolute most critical metric for judging a rig's ability to maintain rotation without stalling out down there. Which brings us to a crucial point. Torque limits are hard operational boundaries. They are not mere guidelines. Working through a tight hole section with too much force, meaning you exceed that rated torque even briefly, can catastrophically snap or twist off the drill string entirely. That's a multi-million-dollar mistake, for sure. Now, since snapping a pipe is completely out of the question, let's look at the rotary table, our essential backup system. You'll find twin hydraulic rotary tables sitting right down at deck level. They act essentially as large horizontal turntables, spinning the string from below rather than above. And they're sized to reflect the different casing requirements of the wells. So you have a 75.5-inch main rotary table and a 60.5-inch auxiliary one. I love this comparison to really make it click. Think of the top drive as a modern cordless power drill, functioning continuously from any position. The rotary table, that's your incredibly reliable hand-cranked brace. It still turns the screw, it definitely gets the job done, and it takes over flawlessly when that power drill needs a battery change or, maintenance, so operations never have to stop. Layering these systems is what guarantees continuous operation. We have independent twin units for both the primary top drives and the backup rotary tables. A failure on one well's primary system absolutely doesn't shut down the entire operation because there's always a proven backup ready to take over. So we've explored the massive forces used to spin the pipe and the vital importance of redundancy. But that leaves us with a pretty provocative thought. Once you have all this torque, the automated mechanical ballet required to physically connect all that heavy tubular steel safely on a pitching deck, well, that's another engineering marvel entirely. Honestly, how do you handle thousands of tons of pipe without crushing the crew? We'll leave you to ponder that one. Thanks for joining me on this explainer.